Welcome to True Projects. In this video, we are going to explain about the project title Brain Tumor Detection Using Machine and Deep Learning. Before diving into the execution, let me give you an overview of the project. Brain tumors are abnormal growths of tissue that can develop inside the brain or the central spinal canal. They vary in size, location, and how fast they grow. When someone has a brain tumor, it can cause different kinds of problems depending on where it is. For example, it might make it hard for them to remember things, speak properly, or even some may be paralyzed. On top of that, brain tumors can also affect a person's emotion, making them feel anxious or depressed. In severe cases, these problems can be really serious, making it difficult for someone to do everyday things like walking or talking. Traditional brain tumor detection methods like CT, computed tomography, MRI, magnetic resonance imaging, clinical assessment, biopsy are crucial but limited in sensitivity and cost, emphasizing the need for more accurate and accessible diagnostic approaches. To address the limitations of traditional methods, the author proposes machine learning and deep learning algorithms. Machine learning algorithms like KNN, K nearest neighbor, random forest, and deep learning algorithms like CNN, convolutional neural network, and VGG16 are utilized in the project. By utilizing these algorithms, the project aims to enhance brain tumor detection accuracy from MRI scans. As an extension, we have proposed a decision tree and voting classifier to further improve the performance for detecting brain tumor from MRI scans. Front-end integration. In this project, we have integrated Flask for building the web application to deploy our project. Flask provides a user-friendly web interface for this project, handling user authentication and image uploads, enhancing accessibility and usability. To implement this project, we need software and hardware requirements. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project, which are KNN, K nearest neighbor, random forest, CNN, and VGG16. These are the algorithms which are proposed in the base paper, and these are the algorithms which we have proposed to further improve the performance. And here the voting classifier outperformed the other algorithms, and that is the reason we have deployed it in the front end. Now let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. So here this is the dataset folder. In this dataset folder, we are again having two folders named as no and yes. In the no folder, we have the MRI scans of the brain which do not depict brain tumor. And in the yes folder, we have the MRI scans of the brain which contain the brain tumor. All these images are used to train the models. And here in the final folder, the data set is split into training and validation. In the training folder, again, we are having the no and yes folder. In the no folder, we have the MRI scans of the brain which do not depict the brain tumor. And in the yes folder, we have the MRI scans of the brain which contain the brain tumor. Similarly, in the validation folder, we again have the no and yes folder which contains the brain tumor images. So all these images are used to train the models, and the images present in the validation folder are used to evaluate the performance of the model. And here, this is the output folder, which again contains the no folder and the yes folder. In the no folder, we have the MRI scans of the brain, which do not contain the brain tumor. And in the yes folder, we have the MRI scans of the brain which contain the brain tumor. This is the sample folder in which we have the test cases for both no and yes. So here these are the MRI scans of the brains which do not contain the brain tumor, and all these images will be used during the execution. And here in the yes folder, we have the MRI scans of the brain which contain the brain tumor. So these are the test cases which we will use during the execution. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are new users, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered. So click on I'm already a member. So here we need to enter the username and the password which we have registered, which are static, and then click on login button. We have logged in successfully and we are redirected to the prediction page. So here we need to upload the MRI scans of the brain, and after uploading the images, the application will detect whether brain tumor is detected or not. The uploaded image should be less than 500 KB in size. So click on choose file to select the image. So from the test cases folder, from the no folder, I'm selecting this image. So here we can see that the image is loaded. Now click on upload button. So here this is the uploaded image, and here we can see the result. The patient is not diagnosed with brain tumor. It means that the patient is not having the brain tumor. Now let us upload some more images. Click on try again. Click on choose file. So this time I'm selecting this image. Now click on upload button. So this is the uploaded MRI scan of the brain, and here we can see the result. The patient is not diagnosed with brain tumor. Click on try again. Let us upload some more images. Let us upload the images from the test cases from the yes folder. So here I'm selecting this image. So the image is loaded. Now click on upload button. So this is the uploaded image, and here we can see the result. The patient is diagnosed with brain tumor. It means that the patient is having the brain tumor. Now let us upload some more images. Click on try again. Click on choose file. Let us upload the images from the test cases itself. So I'm selecting this image. Now click on upload button. So this is the uploaded image, and here we can see the result. The patient is diagnosed with brain tumor. Click on try again. Let us upload some more images. Click on choose file. Let us upload the images from the dataset itself, from the final folder, from the training folder, from the no. So here I'm selecting this image. Now click on upload button. So this is the uploaded image, and here we can see the result. The patient is not diagnosed with brain tumor. It means that the patient is not having the brain tumor. Let us upload some more images. Click on try again. Click on choose file. Let us upload the image from the training set, from the yes folder. So I'm selecting this image. Now click on upload button. So this is the uploaded image. So here we can see the result. The patient is diagnosed with brain tumor. Click on try again. Let us upload one more image. Click on choose file. So this time I am selecting this image. Now click on upload button. So here this is the uploaded image, and here we can see the result. The patient is diagnosed with brain tumor. It means that the patient is having the brain tumor. In this way, just by uploading the MRI scans of the brain, we can detect whether brain tumor is detected or not. Now click on about link here. So here, these are the comparison graphs for different evaluation metrics, which are accuracy, precision, recall, F1 score, specificity, DIE score, and Jacquard index. So on the x-axis, we have these scores for different evaluation metrics, and on the y-axis, we have the algorithm name. So the algorithm which is performing best will be used for prediction. Now click on sign out button here. So in this project, we have built a system that can detect whether brain tumor is detected or not using machine learning and deep learning algorithms. And we identified that the voting classifier outperformed the other algorithms, and that is the reason we have deployed it in the front end. The project underscores the importance of using machine and deep learning for early and accurate brain tumor detection. By harnessing advanced technologies, we can improve patient outcomes and drive progress in neuro-oncology.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.